The half-life of cesium-137 is 30 years. So we have given, okay, before I write that, remember this theorem. This function y of t is equal to y at initial state y0 times e raised to power k t. So we have t is equal to 30 years. Suppose we have a 100 mg sample, and initially we have the sample 100 milligrams. Find the mass that remains after t years. How much of the sample remains after 100 years? And after how long will only 1 milligram remains? Okay, so since you can assume that, like, suppose let m of t be the mass of cesium 137, however you want to go with it, or p or anything, let's just go with the y. So I don't want to make any confusion. So this is just to practice and understand the problem more than finding the right variable name. Okay, so we have this equation y of t is equal to, pay attention here. It says the half-life of cesium is 30 years. The time we have given 30 years is for, so a half-life. Suppose the half-life of cesium, so we have t 30 years. Y of t is, which is half of 100, which is 50 milligram. So 50 is equal to y of 0. Initially we have 100 milligram. K is constant here, and t we have 30. 30k. We have left 1 half is equal to, since this is exponential, just multiply by natural log on both sides. So we have natural log 1 over 2 is equal to 30k, and solving for k is equal to, divided, right? This gets divided here. Hopefully I'm correct about this reasoning, but I think if we just simply solve this value, if we just pick your calculator, natural log half divided by 30, this is simply going to be 0.023 negative. Um, but maybe the calculators are not allowed, or we are looking for the accuracy, because this is, when we convert this into the decimals, because it's a big number, but we just keep to few decimal places and it's gonna reduce the accuracy. So I don't know, whatever the explanation is, but let's just simplify this further to, because we know that natural log a over b, we can write this as natural log 1 minus natural log 2 divided by 30. We know that natural log 1 is 0, so we are left with natural log negative over 30. This is what we have for k. So we know that k is equal to negative natural log 2 divided by 30. And now find the mass that remains after t years. This is why it was better to write y m instead of y, as we have replace the y with p in the population one. So however it works for you guys. Okay, so the equation we have now is y of 0, the initial, the mass remains after t years. We are asking about the years here. So we have that the sample 100 milligram at the initial stage, e raised to the power k. The growth factor is negative natural log 2 divided by 30th times t. And if you simplify this, pretty sure you guys are good at this. This is simply saying e raised to the power natural log 2 multiply by negative 1 over 30 t, right? No effect. Same thing, we just worry a little bit because we know that e to natural log 2 simply equal to 100 times 2 raised to the power t over negative 30. So here is our equation. 100 times 2 raised to the power negative t over 30. So let's look at B now. How much of the sample remains after 100 years? Simply plug in the values here. Y of 100 is equal to 100 times 2 raised to the power negative 100 over 30. Let's see what we come up with. Where is my calculator? So 100 times 2 raised to the power negative 10 divided by 3. So this is equal to, after 100 years, only 9.92 milligram sample remains. Let's look at C. After how long will only 1 milligram remains? Now that's a tricky one. Okay, I'll take this original equation that we had. Y of t is equal to 100 times e raised to the power negative natural log 2 divided by 30 times t. So we are asked how long, after how long will only 1 milligram remains? So that means we have this unknown 1 is given, and times t. So we are solving for t here, correct? I think the best way is if I just write the simplified value here. Or what if I just continue with this? Let's see if there's any difference. So divided by 100 on both sides, we are left with 0.01 is equal to times t. Multiply with natural log on both sides. This is e to the this is simply going to be natural log e raised to power this is simply going to be natural log 2 divided by 30 times t. Okay, so t is equal to negative, no, t is equal to, so cross multiplication, right? So natural log 0.01 multiply by 30 divided by negative natural log 2 is equal to t. And now let's bring up our calculator. What is natural log 0.01 times 30? Okay, so this is negative 138 divided by, it's actually negative 130.1. I'll take up to two decimal places here. 3 divided by negative of natural log 2, or natural log 2, right? Negative is there. And what is so this is, and now natural log 2 is equal to 0.693147 something, but I'll just take up to three decimal places and don't forget the negative. So negative, negative, positive is equal to t. So we have time is equal to 138.155 divided by 0.693, which is equal to 199.357. So I'll just round up and write this as t is equal to 199.4 years. And this is your answer. I hope this helps. Thanks so much for watching.